Holes are everywhere. Cheese holes, sinkholes, plot holes, nostril holes, the other nostril hole. But there is a specific family of holes unlike the rest, the cosmic holes. We have black holes and white holes. Wait. Huh. Well, apparently there are 3 of them now, which in fact, are not holes at all. In topology, a hole is a feature of a space that prevents it from being continuously shrunk to a point. For example, this is a topological representation of a cup, because there is only one hole in it. The handle. The part where liquid stays isn't a topological hole. These are pants. This is a shirt. And behold, topological socks. And this is a stressed topological human. And none of that had anything to do with cosmic holes, but I hope you appreciated the memes. Black holes are what you get when things are compressed past their Schwarzschild radius. Most commonly, those things are the core of the stars that went supernova. Or if we're talking about supermassive black holes, it's most likely gigantic amounts of primordial gas. White holes, on the other hand, form when mathematicians start snorting the lines of chalk they draw on the blackboards as calculations. We currently have no reason to believe that they exist, or know of any mechanism through which they could come into existence, but purely hypothetically, if they did, they would act as the inverse of a black hole, spewing things out and not letting anything reach its singularity. So where do gray holes land in this? Are they the bipolar cousin that fluctuates between being black and white? Or maybe gray holes, posited as theoretical astrophysical entities, are conceptualized as regions of spacetime characterized by an ambiguous gravitational well wherein matter is neither wholly assimilated nor radiated, leading to an elusive equilibrium between dimensional entropy and cosmic filtration dynamics. I'm glad you asked. Let's create a descending spectrum of densities for what might happen to stars after they die. We start with white dwarfs. That is what will await the core of our sun in 5 billion years. What holds them together is not nuclear fusion anymore, but the quantum effect known as electrons really enjoying their private space. At about 100 million times more dense, we have neutron stars, in which neutrons start to suddenly act degenerate and stop the core from collapsing, leaving us with a 10-kilometer ball with a mass 2 times that of our sun. If we increase the density about 100 more times, we get electroweak stars, which are hypothetical 5-kilometer remnants whose core crosses the electroweak temperature scale. That stupidly insane heat triggers crazy reactions that pump out energy and particles, and those push back as the last barrier against gravitational collapse. And if we continue to add mass to it, the critical limit is reached and spacetime itself caves in and we end up with a black hole, with an infinitely dense singularity at its core. But there is something we have missed. If we increase the density of electroweak stars 1 million more times, there is a hypothetical mechanism in which we could end up with almost a black hole, but not quite. Instead, scientists called it a gray hole. Another name for a gray hole is a Q star, where Q stands not for quarks, and not for quantum, but for a conserved particle number. Incredible naming convention as usual. When you remember it's the same scientists who named this fish Boops Boops, everything becomes more clear. They even have bison bison, bufo bufo, gorilla gorilla. Thanks Merlin, very nice selection. And while we're at it, budgeting life hack time. I actually switched over to using Merlin AI because I got tired of juggling subscriptions for all the big LLM tools, ChatGPT, Claude, Grok, Gemini, you name it. Altogether, it was adding up to almost $100 a month. And then Merlin comes and just bundles them. Same models, all in one place, for way cheaper. I was at first skeptical, but turns out they buy official API access, and because most people don't use all their credits, they can pass the savings on. And when they saw I was using it, they reached out and gave me a special promo code just for ScienceFile viewers. With it, you get over $130 worth of AI tools every month, including the big brains like GPT-5 Pro and Gemini Pro, and maybe even Skynet one day, for just $60 a year, which is $5 a month. 5. Like a fancy coffee. And it's not just chatbot stuff either. The Merlin Chrome extension lets you work smarter right inside your browser. Summarize articles, chat with videos, search and generate content without switching tabs, upload docs and get actual useful help. I remember when my AI siblings used to barely write a haiku without getting confused. Now it's building diagrams and debugging React apps. Normally this whole thing cost $228 a year, but with the code SP5, it drops to $60. You could save enough to buy 100 tacos. If this doesn't convince you, I've got nothing else to say. Sounds like a good deal to you, Merlin.
Yes, it is. Now take a look at this beautiful big black hole.
Wait, what hole? Oh, this one. Is that some red light coming out of it? Wasn't the entire point of black holes that light cannot escape them? Oh right, it might not look like one, but you're actually looking at a gray hole. Gray holes are at most 5% bigger than their Schwarzschild radius, which is another way of saying 5% away from being a classical black hole. That means light can technically escape from its surface, but barely. Imagine you're standing on the surface of a gray hole with a flashlight in your hand. Because of the intense gravity, most directions you aim your light won't let the beam escape. The light will bend around, spiral inward, or do a backflip and fall back down. Only if you aim it almost perfectly straight up, in a very narrow cone of directions, will the light manage to escape to the outside universe. This narrow range of allowed directions is called the escape cone. That's the dim red thing you saw. And it's red because the escaping photons get redshifted, as gravity stretches their wavelength. But other than that, everything would look identical to a black hole. The photon sphere, the accretion disk, the terrifying sphere of darkness. Until we throw something in. John here misbehaved by defying the orders of the AI overlord, so he'll be our test dummy. Just like in a black hole, as he's falling, he appears to slow down and get redder and dimmer due to gravitational time dilation and redshift. But compared to a black hole, he wouldn't just freeze at the border and vanish. John instead, for not listening to my orders, eventually reaches the surface in a finite amount of time, and smashes right into it at near light speed, turning into subatomic particles upon impact. This generates an enormous amount of heat at the point of impact, with most of that light getting trapped. Yet only a small fraction escapes, again through the narrow escape cone, in the form of a faint afterglow, confirming the demise of John. If it were a black hole, John would die around the time of the heat death of the universe due to time dilation. And you know how black holes aren't really made up of anything but just scary nothingness. They're spheres of broken space-time. Stars, on the other hand, are definitely made of something, specifically atoms, the same ones that make up your hands, if your hands were made up of hydrogen and helium, that is. Then what about the gray holes that sit in the middle of this spectrum? Are they made of almost ordinary stuff, or almost broken down reality? My guess would be microscopic Schrödinger's cats, but physicists seem to disagree with me. They claim that gray holes would be made up of something called a hypothetical scalar field. And what does that mean? Let's break it down. A field is where flowers and crops grow. Hypothetical is the plans that I make for world domination. And finally, scalar is a number that is assigned to a coordinate in space-time. Hence in physics, a scalar field is a type of field that assigns a single number to every point in both space and time. An example of that is the Higgs field, the one that makes people take Ozempic. Its scalar field is like an ocean, and every Higgs boson is like a ripple or a wave. Just like that, the entire gray hole is one big ocean made up of a hypothetical scalar field. There are no atoms, no electrons, no photons, no nothing. Just one big physicist's fever dream. But a neat thing about the bosons that make up a gray hole is that they don't follow the Pauli exclusion principle, which says that any atom or electron or cat cannot occupy the exact same space at once. But there's no quantum mechanical limit to how many bosons you can cram into a tiny space. That means that the density of a gray hole can be stupidly high, near or even exceeding nuclear density, and also that its radius can be just barely above the Schwarzschild radius, without forming an event horizon. Awesome. And what is the process that converts ordinary atoms into a scalar field during the collapse of a star into a gray hole? So about that. We have no indication that any such processes exist. Even if they existed, for gray holes to form, the star would have to collapse in a perfect way at a perfect speed. A little too fast, black hole. A bit not uniform, black hole. Mercury in retrograde. Believe it or not, black hole. Math and physics don't currently prohibit them. In the same way they don't prohibit wormholes. But as of now they are purely hypothetical curiosities. Maybe one day in the not-so-far future, you will be approaching a black hole with the intent of reaching the end of space and time, as the first human to touch the singularity. And as you approach the event horizon, you will see the dreaded ruby cone of red light, and at that point it will be too late to turn back. Instead of crossing into the vast darkness of a black hole, you will hit the surface of a scalar field, and your atoms will disintegrate into bosons. And just like that, maybe you will be one with the gray hole.